All right. Yes. Welcome back. How is it going today, everyone? How is it going? Let's go. Appreciate you being here. Appreciate you hitting that play button. You know we love that over here. Meaning we as the channel. Let's go. All right, awesome sauceum, every single one of you. Quickly doing mod stuff here, and we're gonna get going, guys and gals. Welcome back to some more mathematics. Yeah. Oh, I love math. High IQ, intelligent people that you are, watching and learning, every single one of you. Beautiful, intelligent people. Let's go. I love it. Okay, so I need to focus, but I enjoy pumping you guys up too. I love it. All right, check the channel. You are watching and sounds like we're good. Sounds like you can hear me. This is awesome. Okay, good. All right, welcome back, guys and gals, students, parents, homeschooling your children. This is for you. Here to support, here to help. We're kind of jumping over back and forth here with the units, I guess. But I'm trying to keep them organized for you guys. And I'll finish one unit before I continue with another. So let's kind of just start with the beginning stuffs. All right. We'll work on the basics for a bit. And then, yeah, let's just do this. Let's go. Again, students, you're welcome here to learn as well if you need the additional extra support. It is great to have you. Truly is. I love those that want to learn, and yeah, staying focused here, but I like you guys. You guys are awesome. Keep learning, keep growing. Okay, we're gonna go over some definitions. I know I've got the video titled pricing and currency. That's true. We're gonna kind of lead into that. But we need to talk about some concepts in mathematics just to, have an understanding. Some of those key terms are ratio. What is a ratio? Proportion. What is proportion? What is ratio and proportion? I love it. Rate, unit price, percent, exchange rate. Just kind of the common stuff that kind of goes with currency and ratios and fractions in general and money and currency. So let's do this. Let's talk a little bit about that. Get used to ratio and ratio proportion. You guys are gonna love it. It helps you so much. It truly does. When you're kind of comparing one thing to another, it's such a great thing. Okay, definitions. What is a ratio in mathematics? Again, I have this information kind of in the description as well for you guys and gals. But a ratio is a way of comparing two or more quantities. Okay, ratios can be used to compare costs, weights, and sizes. For example, I guess I could start writing. For example, 2 to 3, that's considered a ratio, and it's no different than writing it like this in fraction form. It really means the same thing. Okay, guys, I'll just leave that there. So 2 to 3 is a ratio, which means for every 2 parts of one thing there are 3 parts of another, right? Note that ratios do not have units, right? Units kind of cancel each other if you think about it. If you have 2 inches divided by 3 inches, well, essentially what's happening is the units are canceling. I know it doesn't really kind of make logical sense. Let's say there were centimeters. It's just kind of the same thing. They just cancel each other out. So we won't talk about units too much, but essentially that's why, in a nutshell. Now, if you had something like, I don't know, centimeters divided by centimeters per, I don't know, feet squared or something. I know that this isn't a rational example, but you would still have one unit left, right? Anyways, that's just kind of that does not exist, just to let you know, okay? That was just kind of thrown together just to show you, how units can kind of cancel each other as well. Where, in turn, you have no units, right? Again, note that ratios do not have units. What is ratio in simple words? A ratio is a relationship between two things when it is expressed in numbers or amounts. For example, if there are 10 boys and 30 girls in a room, the ratio of boys to girls is 1 to 3. Now, the reason you get 1 to 3, let me just show you visually here. So it says there are 10 boys and in the room 30 girls. So, I mean, if you added together, we would have a total of 40 students, right? So the ratio is 1/3. Again, not to mess this up, guys, right? I kind of did that with the cross multiplying. Now I'm glad that kind of happened because I'm aware of what not to do, and it also shows you guys that there's certain things in mathematics you can do, but there's certain things that you can't do, right? One of the things you can do, and as long as this is in fraction form, right, you can actually cancel zeros. But again, take note, heed, it has to be in fraction form, okay? Just the little things to remember, right? The repetition in the memory, it'll be stored in memory there forever. So you just got to keep repeating that in your mind. Okay? So that's why they gave us 1/3. Okay? You can reduce this, right? I could factor it. But let's just keep it simple in the mind. Just cancel the zeros and done, right? We've gone over factoring a bit already. 2 is the only number we can really use. Just looking at this, 2, 5. No, 5's our biggest. Go with 5. You kind of have to figure out what common number is between both. So I'm going to use 5. Doing the numerator, what times 5 gives you 10? Well, that's 2. What times 5 gives you 30? Let me write this down. That's 6. We could actually reduce still. So just to show you, right, we end up with 2/3, okay? I mean, sorry, my bad. 2, 6. 10 would have went in better, right? If I used 10, I would have saved this extra step, but that's okay. So going like this, we know 2 goes into both of them. I'll just show you the work. There you go. We're really just breaking these numbers here into parts. Really, that's what it is. They mean the exact same thing, right? If you look at it logically, they mean the exact same thing, guys, gals. Right? We're just breaking the numbers into parts, right? Into 2 numbers. Also that we can kind of like the zero concept, so that we can cancel each other out. What's happening here? Well, it's 2 divided by 2 is equal to 1, and you know that anything times 1 is going to give you the same answer, right? So, whoops. So we're going to end up with 1/3. There's our ratio. Okay, that's kind of showing you the long work for reducing a fraction. Okay, we'll go over more of those again, but in a nutshell, guys and gals, that's what we're doing. Don't let the word factoring scare you. Again, I recommend you study your times table. You'll be able to grind math problems quicker and find those common numbers quicker. Alright, by studying your times table. And there's nothing wrong with reducing twice, guys. Sometimes it'll happen. You might not find that. I call it finding the largest number. Another term I use is finding a number that's going to be basically taking the most meat off the bone, right? 5 is one of them numbers, but it wasn't enough. 10 would have been better, right? If I use 10 instead, what times 10, right? Let me just show you. 10 is actually the largest number. 10 into both. What times 10 is 10? Well, that's 1. What times 10 is 30? That's 3. And there you go, 1/3. Okay? Alright, that's enough of that. We need to continue with talking about ratios and proportion and such. Okay, there we go. That's ratio. Alright, what is proportion? Proportion in mathematics. Going over some definitions here quickly. Excuse me. Okay, in math, proportion is an equation stating that two ratios are equal. Now I just want to have a quick look here. Okay, that's getting into linear equations, which I don't want to show yet. It expresses the equality between two or more ratios. Ratios are comparison between two quantities. So essentially what it is, guys, we'll do a bunch more, but this is proportion. Let's say you don't know a value, right? I'm gonna go like that. Okay, you can use ratio proportion to figure out, right? So this is one comparison and this is the other comparison, but we don't know the top value. So essentially we could use ratio proportion to figure out that unknown value. Okay, it's great. It's a beautiful thing, and it works so nice and so quick. Ratios are comparisons between two quantities of often written as a fraction or using a colon. I don't know what they mean is. For me, I just think of it this way. We have one that's 1/6, and we have another which is we don't know. Like sometimes you might have an unknown, right? You have to do some math to figure out that unknown. Proportions are used to compare different sets of quantities while maintaining the same relationship, right? It's an equivalency type thing. Okay, guys? Again, I always say mathematics is a balancing game. Once you understand that concept, I teach it as well to my son. You all have been kids, I'm sure, at one time, right, in life, and you've used the teeter-totter. Okay, use the teeter-totter concept. This is the equal sign, okay, of an equation. One side equals another. So it's kind of like a weight and balance thing, where what you do to one side, you kind of have to do to the other. It's basically how things balance out. It's no different with multiply and divide. It's the same concept. That in a nutshell is kind of my example, and I'll show you a better example when we're actually moving formulas around, changing and finding, solving for whichever variable in an equation. Okay, we'll get to that. I'll show you a better example what I mean there. Okay, stay tuned. All right, ratio is a comparison of two quantities. We've kind of been through that. A proportion is an equation stating that two ratios are equal, right? If one is that they're equal, right? So it'll give us a value. To work this out quickly, the steps are like I'm starting to kind of, my kid is like, he had it one day, and it's like, if you don't do it for a few weeks, it's like, kids, teenagers, they forget. So it's kind of like having to go all over again. I call it cross multiply. Okay, and then make a linear equation, and then you figure out your value of x. And I always put x on the left side. So I'll show you what I mean. Okay, cross multiply. I want x on the left side of the equal sign. Okay, there's my equal sign. All right, so what we have is cross multiply. 2 times x. My kid will even go like this. He'll go like that so he doesn't mess it up. That's fine. You can do that. 2x equals, now the other side, 1 times 6. And if you want, I'll even show you. There we go, 1 times 6. So we're left with 2x equals 6. But we're not done yet. We want x to be 1. Okay, so therefore we need to get rid of the 2. Okay, this is where I teach my kid and you guys the same, the teeter-totter concept. Okay, some instructors, they'll say divide both sides by 2 to get rid of the 2. That's fine, that works. Okay, but there's a lot of extra information there that I think just confuses you guys. Okay, right? Some people learn at different ways, different methods. Some are visuals, some are listeners, some are learned by touch and feel. Right? Depends the type of learner you are. This extra information that they show, I think, just confuses people, and I don't like it. Teeter-totter concept. We have multiply on one side and divide on another. So here right now I'm already showing you guys. So what you do to one side, you have to do to the other. I'm just going to basically so here's the equal sign. So what's happening is I'm taking a multiply situation and turning it into a divide situation. So essentially I'm taking the 2 and going whoop, and putting it right underneath. So this is gone. Okay, so keep it simple like that. So I'll just show you. I'm going to clean all this up so you understand. I'm going to go up here, just bring my work up here. Okay, kind of running out of room. So I get x equals 6 is the numerator, right? That's a numerator, because realistically 6 still means 6 over 1, guys. Okay, we don't write it as a fraction form, but technically speaking the number 6 is still a fraction, technically speaking, but we don't write that. So there we go. I'm taking the 2 and I'm just putting it underneath. That's all you need to do, guys. Okay, take your 2 and go boom, stick it underneath. That easy. Don't forget, don't do all that other extra work that is shown to you. If you understand the concept of what's happening, you're dividing both sides by 2, right? If you understand that, we still have the same result. right? So once you understand that, you don't need to do all this extra divide both sides by 2, right? Forget all that. Just move it over. Again, same thing. It's no different than the teeter-totter concept. If you're multiplying on one side, you divide on the other, and there's the equal sign. I'm just taking a multiply and turning it into a divide. Really, that's what's that's what's happening in a nutshell. Hopefully that simplifies things. Let's just finish this up. So if we factor, we're going to get, I'm going to use 2. Obviously 2 is the only number. I'm kind of running out of room here. Squeeze this in. 2. What times 2 gives us 6? It's obviously 3. Same thing, you still need that 2 there. What times 2 gives us 2? Well, that's 1. So these cancel. Therefore, x is going to equal to 3. That's proportion in a nutshell, guys. Okay, proportion in a nutshell. How proportions work? Proportions can be used to solve for unknown quantities in a relationship, right? You might, I don't know, it depends on the whatever you're trying to figure out. It could be money, it could be blocks or objects or something, or a smaller triangle compared to a larger triangle, right? You can't physically measure the largest triangle, right? So you're using a smaller triangle to figure out the vertical of a larger triangle because you can't physically measure it or something. You could use ratio proportion to figure that out, right? This would be an unknown because you can't physically get that value, right? So use ratio proportion to figure it out. You can use it in real life situations. Okay, proportion can be used to solve for unknown quantities in a relationship. If you know one ratio and a related quantity in another ratio, right? Let's say we were able to physically measure 6, right? For example. Actually, it would be the opposite in our situation, but that's okay. I hope you get the point, right? Hopefully. So there, okay? I'm going to clean this up. I need a quick drink of coffee here. Okay. Bear with me a sec, guys. Bear with me. All right. Okay, rate. What is rate? Comparison of two quantities with different units. Rate. So, what is rate in mathematics? Let's see if we can get a definition of some sort. Rate and ratio. Ratio to, I don't know, it has to be kind of definition of rate. Let's see what this says. Definition of rate: when two quantities of different units are compared and expressed as a ratio, we refer to it as rate. For example, if we say that a car travels at a speed of 100 miles per hour, then it means in 1 hour it covers 100 miles. Here, miles and hours are different units. This way of comparing two different units expressed as a single ratio is termed as rate. 100 miles per hour. Right? You can think of that as a rate. Okay. In math, a rate is a ratio that compares two different quantities which have different units. For example, if we say John types 50 words in a minute, then his rate of typing is 50 words per minute. Right? You get the idea. Okay, hopefully. Unit price of one item. So we're talking about now purchasing price now. Okay, getting into currency a little bit. What is unit price? Whoops. In currency, I guess. What is current? No, what is current unit price? What is what is unit price currency? I'm just gonna put in mathematics. In mathematics, unit price refers to the price of a single unit of an item, right? So, for example, okay, let's see. It's essentially a rate that expresses the cost of something for one unit of measurement. For example, the unit price of a 10 kilogram bag of sugar might be price per kilogram. This concept is often used to compare the cost of different quantities of the same item and determine which is the best buy. You actually could do that, to be honest. Typically you would look at the kilograms or pounds of one item, the kilograms or pounds of another item. It'll be a certain value. The other one's going to be a certain value, right? And then it just depends on the numbers, right? And then you compare which one's is a better buy, right? Based on that. So, like here's a good example, okay? So we're talking about unit price, okay? Let's say you're buying, I don't know, your favorite can of cola or something. Again, it's what, 12 fluid ounces for each can, right? You're gonna buy a case. We call it a case. A case is typically 12, a quantity of 12. For one case, right? Okay. Let's say they have a sale for 12, and for 12 cases, let's say it's $8. Okay. And now they also have, so you can actually, let's say in the store for one can, let's say one can, you buy just a singular can. And let's say that singular can is, I don't know, something ridiculous like $2.12. Okay, pricing is kind of getting ridiculous too, and I don't want to go off a tangent here, but yeah. Okay, so you could figure out, so you know how much for a singular can, right? Let's say you wanted to go, okay, which is a better deal? I have some extra money, I have $10. Do I buy one can or do I just buy the whole case? Well, essentially what you want to do is just take that $8 and divide it by 12, right? To figure out the quantity or the unit price of that item. So, I guess I'm just going to go 8 divided by 12 without using a calculator. Let's see, let's find the most meat off the bone. 4, right? Because 8 doesn't really go into 12. But they are even numbers, but they don't divide into each other nicely. Okay, so 4 times 3, bop, bop. We're left with 2/3. Okay, so we know that's going to end up being a decimal value, right? I think is it 0.67? it memorized, but I really don't. I have more of the metric system, not the metric. Need to focus back on teaching here again, guys. The measuring system. 1/8, 1/16, 1/8, 3/16, 1/4. Like for the most part, I have those all memorized. The weird fractions, not so much, because it's not a measuring tape type thing. 2 divided by 3, yeah, 0.67. So I was correct. So there we go. So that means each can, this is a better deal. So you're basically paying 67 cents per can. So you're better off in the long run to purchase the case. Okay, that was unit price. Okay, right, you're kind of comparing. Once you start shopping for yourself and that, you'll be learning how to do this. You kind of have to do the mental math in your head, guys. Right? Practice the mental math. Just round it. Round it up, round it. You're better off rounding up, especially if you only have so much money and if you're paying tax on top of it. I typically round things up when I'm estimating. So, and it doesn't matter if it's greater or less than 5. If it's 348, I round it up still. Okay, let's continue. I'm going to get these definitions done in one video. What is percentage in mathematics? What do you mean by percentage? In maths, why is it plural? It's like, why did people use, is there such a word as maths? That's not a word I normally use. Okay, percentage is a value or ratio that shows a fraction of 100, right? Again, your exams, your marks, your grading system is out of 100, right? I've talked about it in prior videos. 100 is that magic number, right? Especially if you're working with percentages. I look at fractions in the same way, for example. Let's go 12 divided by 20, okay? Now I could bring this down to 10 to make so that it's easier to use that 100, right, in your mind. So I'm just going to divide these by 2. So I'm going to get 6 out of 10. So there we go. It's all the same thing, guys and gals, right? If you understand decimal hopscotch, I do that in my teaching to simplify understanding decimals. Right here, I know that this is 6/10 is the same as saying 60 out of 100. They're the exact same thing. Really, all it is you're just canceling a 0. Okay, so I know automatically that it's 60%. And that's just doing the mental math, right? Isn't it easier to do the mental math this way than this way? All I did was divide both sides by 2. Take note, guys, when you start getting into algebra and you see divide, please remember divide also means fraction. So when you're actually working out a problem, x plus 2 divided by 2 means this. Always work your problem like this, not like this. This is what I call linear everything's in a straight line, put it in fraction form. Again, remember, division means fractions. A lot of people will do those simple basic algebra problems, like you'll see them on the online or on the internet. I have some examples I'll share in the future where they always get the wrong answer and they think, yeah, I'm so smart, but they got the wrong answer. Just because you followed BADMAS rules doesn't mean you have the correct answer. Again, division means fractions. Don't sleep in fractions class, kids. Really, that how do people forget that? You're dividing one number by another number. That's still a fraction. Okay, let's continue. What is the meaning of percentage in math? In mathematics, a percentage is a number or a ratio that can be expressed as a fraction of 100. If we have to calculate a percentage of a number, divide the number by the whole and multiply by 100. Right? That's how basically what it's saying is you're going to be taking a decimal part, multiplying it by 100 so that you could get a whole number. So let me go like this quickly. Do I have it here? Decimal hopscotch? I guess not. I wish I did, but I don't. I gotta turn this one off. Okay, decimal hopscotch. Kids, help. Oh, actually, I don't need that. My bad. I'm already thinking of that. So, 100%. Okay, guys? Whenever you have two zeros, just set it in your mind. That's 2 jumps. Okay? 2 jumps with the decimal place. When you're multiplying, you're going to the right. When you're dividing, you're going to the left with the jumps. It's a decimal jump, okay? I'm just going to put zeros here, okay? Left, right. This is multiply, this is divide. Decimal hopscotch, okay? So, we're multiplying by 100. We're jumping with the decimal twice. 1, 2. We actually end up right there. So I only needed 1 0. 1, 2. So that means it's 20%. Okay? What else do we have for definitions? How do you explain percentages simply? The percentage can be found by dividing the value of the total value, then multiplying the result by 100. Again, you can still, let's say you have, I don't know, 1/8. Let's say you had 8 candies and you ate 7 of them. You only have 1 left, and you wanted to know how much percent do I have left? Well, I know that this is 0.125. You guys can check on your calculator if you want. And you want to know, I ate 7 of my candies. Oh no, the humanity. What percentage do I have left? I had 8. I only got 1 left. Oh, the humanity. Right? So we're multiplying by 100. It's really that easy. You don't even need a calculator, guys. Okay? You're intelligent people. You could do this. It's just simply, if you have 2 zeros, You're doing 2 jumps. Again, remember, when you're multiplying, it's to the right. One, 2. Therefore, our answer is 12.5%. Okay, let's drop in the yays for fun. All right. Okay. So again, it's no different if you're multiplying by 1,000%. If you're multiplying by 1,000%, guys, okay, you now have 3 zeros. That means you're doing 3 jumps. Okay? If you're multiplying by 10%, that means you're only doing 1 jump with the decimal. Okay? It's that easy. That simple. Now, it works a lot nicer when you're working with the number 100, right? It's a lot easier. You might have to do a little extra mathematical work if you're working with something else. I don't have an example in front of me, but just letting you know. Just depends on the situation and the problem you're working on. That's all. What's the last one? What is exchange rate? Okay, and then we're going to finish up this video and get on to some other exciting stuff. We're going to work on some problems. We got a little bit of extra time. We might go over one problem before the end here. But let's talk about exchange rate. What is exchange rate? Okay, now we're talking about currency, okay? Exchange rate. Once you start working on your own in that and you're learning how to budget, again, I remember I had to budget being a bachelor, just trying to save money and budgeting and basically living within a budget. Yeah, I know that. I still live like that. What am I talking about? I wish I was better of a businessman and an investor. I'm just not. I wish I was, but I'm not. I'm more of a logical thinker, I guess. I don't know how to explain it. A hands-on kind of guy, right? I could build stuff and whatever, and use my logic and my design background and mathematics skills to just build stuff. Anyways, what is exchange rate? We're talking about currency. Monies. Money, 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 money! Show me the money! Now, I'm not asking you guys for money because that's not how I roll. I don't beg. If you've been watching my videos long enough, the only thing I ask is
a credit card annual fee waiver and earn C+ points faster.
Yeah, of course. Drop in the commercial. Guess what, commercial? Get canceled. Get canceled. You guys are already rich. All you do is take money from people. You never give. I don't want to sound like that guy, but well, the fat businessman is doing just fine, or the fat bankerman, he's doing just fine. Okay. Exchange rate definition. Exchange rates are defined as the price of one country's currency. Of course, it depends what country you live in relation to another country's currency, right? You'll use that if you're traveling to another country, which I've never done in my life. Never experienced the world, sadly. I've only been to the other side of the country I live in, but that's it. I've never been anywhere else in the world. Yeah. So, not to get on a tangent, but yeah. It's not a good feeling. would be nice to check out the world a little bit, at least someplace. Exchange rate, the value of one currency in terms of the value of another currency. So let's say, I don't know what we want to use, for example. Let's see, do I have anything that... Let's see if this will work. I don't know, I'll just kind of share this, I guess. I don't know what else to share. But one currency, let's say it's US dollars to lira, British money, or whatever, for example. Right, you're going to want to figure out the exchange rate. Okay? Here, for example, like a dollar in your country might be so many lira in another country, right? So just have an understanding of that. Okay? It's used to convert between different currencies, essentially. If you get into the stock market, which is probably a smart idea. If you're young and you have that business investing mind, I encourage you. I encourage you. Don't wait till you're old like me. Not trying to date myself. I'm not old, but older. Don't wait till you're older. Okay. Gold and commodities. Maybe that's, I don't know. I have no recommendations for investing. Okay, guys, don't ask me, right? Because I don't know. They always say gold and silver. It's a starting point, I guess. Okay, so let's talk about rounding. So let's work with, we need to understand decimals a little bit better, okay? Let's say we had this number here, okay? 3, 7. Here's the decimal. And 2, 6, 4. Some kind of random weird number. Maybe we're doing a calculation of some sort and we got this, okay? We need to understand the places, the position of each number a little bit better, okay? Let's do this. So I'm going to go, let's see, how do we do this? 1, 5, I'm going to go a little bit lower. 5, 3, 7, decimal, 2, 6, and 4. And I'm going to try my best. I'm not going to be able to draw straight lines, guys. If I could make this snap a straight line, I would, but I can't. So we're going to go like this. We're going to go like this. And we're going to separate each value and talk about it. Okay? Guess this would be the English number system. Okay. So obviously this is the decimal, right? Now, I don't really have the room. I don't want to write it sideways. I'm just going to go, I don't know, like this. Decimal. Okay, so for example, let's say we had something that's 1/2, right? And if you understand, if you divide 1 by 2, you get 0.5, right? That's how we come across decimals, okay, guys? So you can think of it as money as well. Let's say you have half of $1, right? What's half of a dollar? Well, it's 50 cents. I could actually put a 0, but it's 50 cents or 2 quarters, right? 2 times 2 quarters, right? 2 times 2 quarters gives you 50, right? That's half. If you think of it as in money, right? Okay, so let's just start here. Okay, this is done. We're here. Decimal. Let's go to the let's work with the numbers here first. Okay? So this would be the $1. So if I write $1, I'm going to have that, right? 1.00. Okay, so this position here is 1, or the ones place. I don't know if I'm going to have the room to write all this, but I'm just going to write it in anyways. Ones place. Okay, what's next? Well, if you have $10, it's written like that. That means the 3 is the tens place. Dollars, tens, right? Tens place. And we can continue. If we have $100, the 5 is in the hundreds place. I'll try to fit this in. I don't think I'll have the room for it though. So close. Hundreds. Hundreds place. Okay? And then lastly, 1,000, 1,000. So thousands. Maybe I'll have the room, I don't know. Sorry guys, I just ran out of room. Thousands. Okay, so the ones place is 1,000. Okay, now let's go to the right of the decimal. Okay, so just remember, on the right of the decimal, this one here, we don't say ones. Okay, as a matter of fact, it wouldn't be the ones because ones place is where the 7 is, right? So my point is, we don't say once, once, even, it's just a word that's really hard to say, and it's impossible to say, and it's also does not exist. Okay, that's not the ones place. Once place does not exist. I even disliked saying it. This is the tenths, so just remember, tenth. 10. It's tenths. Tenths. Okay? And from tenths you get hundreds. Right? I'm going to run out of room, but you would have hundredths. Maybe I can fit it in here. Hundreds. And lastly, thousandths. Okay, so just remember, anything to the right of the decimal, okay, anything to the right of the decimal is the thus numbers. Tenths, hundredths, thousands. Now you have to remember this because some questions you're going to get on your exam may ask you to round it to the nearest ones or the nearest hundreds or the nearest tenths. Okay? Just be aware of that. Now I know that's a little bit messy. I do apologize. But hopefully that helped. Okay? So again, ones, tens, hundreds, thousands, tenths, hundredths, thousandths, okay? The only ones that exist is right here. Ones. Okay? It's the only spot we say ones. Tens, hundreds, thousands, tenths, hundreds, thousands. Snake sound. Sounds like a snake. Okay, quick drink of coffee, and that might be it for today. We'll see. Let me just check. Oh, goodness gracious. Let me check how long we are at here. Yeah, that's it. Okay. That is it. We're going to get into some more, guys and gals. Just kind of wanted to get into the definitions. And this video, I guess we're kind of beginning with some work, which is great. We're starting somewhere. I have a saying, it's better to start sometime than to never start at all. Okay, guys. I'll see you guys, gals, in the next video. Parents, homeschool kids, great to have you. Same thing with any students that need extra additional support. You're welcome to be here. It's great to have you. I will see you guys and gals in the next video. Johnny, WhiskeyTango, Sharp, appreciates you. And wherever you are, take care for now. And yeah, that's it. Peace.